Okay, here's a practice problem. A ball of mass m attached to a string of length L moves in a circle in a vertical plane as shown above. At the top of the circular path, the tension of the string is twice the weight of the ball. At the bottom, the ball just clears the ground. Air resistance is negligible, and express all answers in terms of m, L, and G. Okay. Part A. And so it begins. Determine the magnitude and direction of the net force on the ball when it is at the top. When it's at the top. Okay. So it's asking for when it's going to be right here. We need the top. So what forces are going to be at play here? So what forces are at play here? The only forces existing are the weight force and the tension force. They're both centripetal forces, but mainly tension because it's what's causing it, regardless of if the mass was over here or mass was over here or mass was over here. The tension is what is going to keep the centripetal motion, and so that is our centripetal force. But since it's at the top, the weight force will also contribute to the centripetal force because it's pointing towards the center at the top. So both of these are going to contribute towards the centripetal motion, and because both these forces, I should say, are pointing towards the center of the circle, they're both going to be positive quantities. So the weight and the tension are both positive. So the sum of the forces in the y direction, because this is the y direction right here. So the sum of the forces in the y direction, which is when the ball is at its top, sorry for that, when it's at the top, will be the weight force plus the tension force. In the question, it states that the tension is twice its weight, so T equals 2W. So we can replace the T with 2W. So instead of this would be W plus 2W, which would be 3W. So the magnitude of the force of the ball when it's at the top is 3 times its weight, or 3W. Or we can also say this as 3mg, because weight is nothing but mg. So this would be 3 weight or 3 mg, and it's going to be pointing downward. Okay, part B. Determine the speed v0 or v initial of the ball at the top. Determine the speed at the top. Okay. So for this, we're going to need a kinematics equation. So, which equation are we going to need? Actually, no, we don't need a kinematics equation for this. Determine the speed of the ball. We know that F equals m v squared over r, right? And they want v initial. So they want this. So solve for that. F times R divided by M square root. That's V, not W. V. That's our speed. And we know that the force here is 3 mg, right? The force is going to be 3 mg. So we substitute that. Square root of 3 mg R over M equals V. The M cancels out because it's the same mass, leaving square root sorry guys, it's technical issues. Okay, so when you simplify all that out, it comes out to root 3 GR. And that is your velocity in the direction. Oh, I forgot one thing. So they said they wanted everything in terms of L. L is the radius here. So it shouldn't be R here. This should be L. This should be L. It's the same thing. It's the same thing as radius, but the radius in the problem is L. So it's better to keep it as L. So that's your answer for part B. Alright. Part C. Determine the time it takes the ball to reach the ground. Oh, I forgot. Okay. The string is then cut when the ball is at the top. Determine the time it takes the ball to reach the ground. Okay. What do they want? They want the time. For this, I'm pretty sure we need a kinematics equation. We know the height, right? We know the height, which is 2L. The height is 2L because this is an L. Ooh, nope. This is an L, and that is also an L. That's 2L, height from the ground. Right? So we know the height. And we know the kinematics equation H equals half AT squared. And we derived this from the kinematics equation X equals VIT, or V initial T, times, or plus half AT squared. And we're given that V0 is 0. VI is 0. Because when the ball is moving horizontally, the velocity will be 0. So that takes out this term right here, leaving out just half AT squared. And that's how you derive this formula. So we know H, 2L, equals half. We know G, we know acceleration G, and we know T squared. So, or we don't know T squared. The formula is T squared. So we solve for T. And so we get 4. When you get the 2 and the G to the other side, we get 4L over G. Running out of space. I'm going to write it here. 4L over G. And take the square root. So that would just be 2 square root of L over G. because according to the distributive rule, oh god, I can't talk today. Distributive rule, you take out the 4, square root of L, square root of G. Keep running out of space. So that would just be 2 square root of L over G. And that's your answer for part C. So part D. Determine the horizontal distance the ball travels before hitting the ground. How much distance does it travel before it hits the ground? So, okay. So we know now the kinematics equation. The distance that it travels is the speed times the time. We know the time, which is that, and we knew the speed from before. The speed was root 3 GL. That was the speed. So I'm going to write that down. And time was that. So if you want to find x, so you multiply 3GL times 2L and G. So you can already say that the G cancels out, and from the distributive rule, the L just remains by itself, and so it would just be 2L root 3. Where do I write that? So when this all cancels out, this would be, because there are 2 L's here, that's how I just said that when you multiply them and take the square root, it would just be 1L. That's how I simplified it. So it would just be 2L root 3. And that's your answer for part C. Or part D, my bad. And that is it. Hope these videos help.